Good afternoon, Geometry Honor students. So it's Mr. Chen again. So today I would like to talk about that similarity triangles, proving the similar triangle by using angle. So this one is a day 2 lesson for chapter 8-2. So identifying the characteristic of a similar figure. Okay, so let's start with the warm-up problem as what we talked about before. So cross multiplication. So this one is just like multiplying the numerator, denominator, and then you want to set that equal to the results of the other numerator times the denominator. So x plus 1, the quantity of x plus 1 times 1, it's x plus 1. And then, so that equals x times x, so which is x squared. So now, for this one, you want to bring everything together to one side. So we got 0 equals x squared minus x minus 1. And you may notice that this one is non-factorable. If this one is non-factorable, so you want to apply that the quadratic formula, which is negative b plus minus square root of b squared minus 4ac all over 2a. So using that quadratic formula, you'll see that this one negative, well, a is 1, b is negative 1, and c is negative 1. Identifying all those elements, and then we plug in a number, so negative b, so negative 1, so positive 1, plus minus square root of b squared, so negative 1 quantity squared, minus 4ac, so 4 times 1 times negative 1. And then it's all over 2a, so 2 times 1. Evaluate it by using PEMDAS, so 1 plus minus square root of negative 1 quantity squared, that's 1. Negative times negative, positive, so plus 4, all over the product of 2 and 1, so it's 2. So the final answer would be 1 plus minus root 5. It's a non-perfect square number, root 5, and the whole quantity, all over 2. So there's going to be two different solutions for this quadratic equation. Okay, so after we cross multiply for the geometric means, excuse me. And now the next one. So figure that's similar. If you see the squiggling line like that, so that means the figures are similar, have the same shape, but not necessarily the same size. So that's what similar mean. So triangle 1 is similar to triangle 2. So triangle 1, it's not similar to triangle 3. So for the similar polygons, so two polygons are similar if and only if their corresponding angles are congruent and corresponding size lengths are proportional. So what that means is saying that angle A is congruent to angle W, angle B is congruent to angle X, so all those corresponding angles, they're congruent to each other. And also the corresponding sides, so showing the proportionality. So AB over WX, which has the exact same ratios as BC over XY, and also is the same as the ratios of CD over YZ, and dA over ZW, so the common ratio, so that's called 3 over 1. Okay, once you reduce all those numbers, so 15 over 5, which is 3. And then 12 over 4, it's also 3. 21 over 7, which is 3. 18 over 6, it's also 3. So the polygon ABCD, quadrilateral ABCD, is similar to quadrilateral WXYZ. So now, check it out the example. So here's what we found. So angle A, while triangle ABC is similar to triangle DEF. So angle A is similar, well, it's congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. Proportionality, so you want to set up 3 different proportionality, the ratios of the measure of all the pair corresponding side length. So this one you can just say that AB over ED is the same as the ratios of BC over EF. And also you can say that AB over ED is the same as the ratios of AC over DF. And then also you can say that BC over EF, which is 2. Once you divide it, it's the same as the ratios of AC over df. Okay, proportionality statements. So check your progress. So determine whether the following polygons is similar. If they are, write a similarity statement. Okay, so similarity statement. So check it out, this one. So 2 over 2.3. So dg over nm. Is that the same as the ratios of dc over nl? Okay, so let's find out. So dE, which is what, 2 over 2.3, would that be the same as the ratios of 1.5 over 1.7? So this one multiplied by 10 top and the bottom, so we got 20 over 23. This one multiplied by 10 top and the bottom with the fractions, we got 15 over 17. And then 20 over 23, obviously it's not the same as the ratios of 15 over 17. So they're not similar. Okay, so now what about the other two triangle here? So for part B, so this one is 57 degree. This one is also 57. Angle J is 48. So how do we get angle K? So in order to get that, it's 180 minus 57 minus 48. So it's 180 minus the sum of this two angle, which is considered 105. And then 180 minus 105, so 75 degree. So angle K is 75 degree. And which is congruent to angle P. Okay, so all three angles are congruent. So that means the triangles are similar. Proportionality statement, so you can just say that JL. So JL along this two angle right here. So over QM, which is the same as the ratios of JK over the ratios over the segments QP. So triangle JLK is similar to triangle QPM. Okay, so here's another example. So triangle ABC is similar to triangle XYZ. So one is smaller, the other one is bigger. ZXY. So the measure of angle A is 60 degree. Measure of angle B, it's 85 degrees. So what's the measure of angle Y? So again, if A is the same, has the exact same measurement as angle Z, so this one is also 60. And also angle B has the exact same measurements of angle X, so 85 degree. So in order to get the third angles of a triangle, we use the triangle sum theorem. So 180 minus 60 minus 85. So 180 minus the sum of 60 plus 85. So we got 180 minus 145 degree, which is 35 degrees. So that would be the measure of angle Y. And here's another one. So triangle BAT, it's similar to triangle DOT. So OT is 15, BT is 12, DT it's 9. And you want to find the length of AO, okay, right here. So again, let's set up the proportionality statement. So one thing that we notice, so AT over OT, we compare the height of the triangle. So this one has the exact same ratios as the base ratio, so 9 over, well, 12 over 9. Okay, so one thing that we notice, OT is what? 15. Plug in a number. So 12 over 9. You can always reduce down the number. So once we find out 18, so we just want to subtract that by 15. And then we can get AO. Cross multiply, or simply this one just reduce. So AT over 15. So that equals 4 over 3. Divided by 3 top and the bottom. Reduce the fraction first. And then cross multiply. So 3 times 18. So that equals 15 times 4. 15 times 4, which is 60. So that means 18 equals 20. So once we get 18, so using segment subtraction postulates, so we can get AO. So 20 minus 15, so then that'd be 5. So here's another example. So given that triangle JHK, it's similar to triangle POM. So triangle JHK, it's similar to triangle POM. So the measure of angle H is 90 degrees. Okay, obviously the figure is not drawn to scale, 90 degrees. So that means angle O is also 90 degrees. Measure of angle J is 40. So that means the measure of angle D is also 40. And then the measure of angle M, it's x plus 5. Angle Q is 1/2 y. So let's find the value of x and y. So angle Q is 90 degrees. So 90 equals 1/2 y. Solve for y. Multiply by 2, so y equals 180. And then to find x, so the measure of angle M, it's x plus 5. So one thing that we notice, triangle sum theorem, 40 plus 90 plus x plus 5, so that equals 180. Combine those like terms, so 40 plus 90, it's 135 plus 5, so it's 140 plus x equals 180. Subtract 140 on both sides, so we got x equals 40 degrees. X equals 40, just without the unit, because that's just a variable. So more example, they're quite similar, so you want to compare that to similar polygons. So given that polygon ABCD is similar to polygon EFGH, so part A, find the missing segment, so FG. So FG, which is this one, it's corresponding to this segment here. So we can set up proportionality statement. So AB over EF. Okay, so they're similar segments. So that equals BC over FG. So AB, which is what, 6, EF is 9, and then BC, so that's 7, over FG, we don't know what that is, so it's x. Again, cross multiply, so 6x equals 9 times 7, 63. So divided by 6 both sides, so this one is not divisible, so just leave it as the way it is. So x equals 63 over 6. And then the rest of that, you want to set up the similar proportionality statement. And then measure of angle F, 90 degrees, because that shows the perpendicularity symbol, the little square symbol. Angle H all the way down here. If this one is 90, well, this one shows that angle D is congruent to angle H, because those two polygons are similar, so that means it's 75 degrees. Angle C, so angle C, it's 125 degrees. Again, all those corresponding angles got to be congruent to each other. And then angle E, in order to get this, so using that, the sum of a measure of all the interior angles of a quadrilateral. Okay, so this one, it's 75. This one is 90. So basically just combine all the angles together of this polygon, and then set it equal to 360. So 125 plus 75, then that would be 200 plus 90, so 290. So x plus 290 equals 360. The reason why it's 360 because that's a measure of all the angles of a quadrilateral. So the way to do it, n minus 2 times 180. Excuse me for a sec.